Hello, my name is William, and in this video we will be looking at number sequence questions. Let's begin. Lawrence makes up a rule for the nth term of a sequence. He uses it to generate this sequence. 3, 7, 11, 15, 19. Circle the rule below that Lawrence used. What does n mean here? N is the position of a number in the sequence. So for the third term, n equals 3. Looking at the numbers in the sequence, what is it going up by? It is going up by 4 each time. A nice way to think of this sequence is, this is the 4 times table in disguise. Let's write this above. We have 4, 8, 12, 16, 20. The 4 times table, we can write this as 4n, because when n equals 1, we do 4 times 1 equals 4. n equals 2, 4 times 2 equals 8. n equals 3, 4 times 3 equals 12. It doesn't matter what n is, because when we times it by 4, we will get a number in the 4 times table. Let's put 4n over here. Now how do we go from the top row to the bottom row? We take away 1. Hence, we have the rule for this sequence. This is called the nth term, or the rule. The answer is 4n minus 1. Try this one for yourself. We have the sequence 8, 13, 18, 23. What is the rule for this sequence? I will give you 10 seconds. The same method as before. Let's work out the difference between the terms. It is going up 5 each time. It is the 5 times table shifted up or down. Let's put it above. 5, 10, 15, 20. How to write the 5 times table? This is 5n, because n can be anything. If n equals 1, 5 times 1 is 5. If n equals 2, 5 times 2 equals 10. If n equals 3, 5 times 3 equals 15, and so on. Above, we have 5, 10, 15, 20. Now, how do we go from the top row to the bottom row? We add 3. Hence, we have the answer. The nth term, or the rule for this sequence, is equal to 5n plus 3. Try this one for yourself. We have the sequence 96, 92, 88. I will give you 15 seconds. This is a bit different because it's going down. It is going down 4 each time, so really this is the 4 times table. Wrong. It is the minus 4 times table. This is a nice way to think about it. Let's put this above. Minus 4, minus 8, minus 12. How do we write the minus 4 times table? Minus 4n. Now how do we go from minus 4 to 96? Add what? I'll give you 5 seconds. This is adding 100, because to go from minus 4 to 96, it is good to go to 0 first. This is adding 4. Then we go 0 to 96, this is plus 96, so altogether plus 4 plus 96, this is plus 100. If we go from minus 8 to 92, it is the same thing. Minus 8 to 0 is plus 8, then plus 92, so altogether plus 100. That means to go from the top to the bottom row, we add 100. Hence, the answer is minus 4n plus 100. We can write this the other way around. 100 minus 4n. When we write it like this, we're showing ourselves this sequence is going down, because we have minus 4 in front of the n. Circle the rule below that gives this sequence. 5, 12, 19, 26. n plus 7. 7n minus 2, 7n plus 2, n plus 4, or n plus n squared. Use the same method as before. I will give you 9 seconds. We are going up 7 each time, so this is the 7 times table shifted up or down. Put 7, 14, 21. 28. This is equal to 7n. How do you go from the top to the bottom row? We minus 2. Hence we have the answer. The sequence is 7n minus 2. One person lays her marbles out in a series of patterns. There are half n plus 1 marbles in the nth pattern. How many marbles would there be to make the 8th pattern? I will give you 9 seconds. N is equal to 8, so let's substitute this in. Half times 8 and then 8 plus 1. Because of BIDMAS, let's work out 8 plus 1 first. This is 9. Now half times 8 is on the outside. This is equal to 4. Altogether we have 4 times 9 equals 36. Therefore in the 8th pattern there are 36 marbles. Let's plug in a few numbers just to see what this pattern looks like. If n equals 1, we have half times 1, which is a half. Then we have 1 plus 1, which is 2. Half times 2 equals 1. When n equals 2, half times 2 is 1. We have 2 plus 1 is 3. So 1 times 3 is 3. Pattern 3. Half times 3, we have 3 over 2 times 3 plus 1, which is 4. So we have 3 over 2 times 4. We can put this over 1, so then it leads to 12 over 2 equals 6. When we look at this pattern, we can see triangles forming. A nice way to visualize this sequence. Which expression can be used to work out the nth term of this series? Minus 1, 1, 3, 5, 7. I will give you 9 seconds. Or is it going up each time? 2. So put above these numbers 2, 4, 6, 8, 10. But how do we go from 2 to minus 1? Or how do we go from 4 to 1? Or 6 to 3? We subtract 3. Notice the top row is the 2 times table, so we write 2n. And then to go from top to bottom row, it is take away 3. So we have it. The answer is 2n minus 3. Here is the rule for a sequence, 2n plus 3. Tell me what is the 90th term of this sequence. How to do this? We substitute n equals 90. Firstly, we do 2 times 90 equals 180 plus 3 equals 183. So the 90th term in this sequence is 183. If you want to work out how this sequence starts, go for it. It starts with n equals 1. Let's substitute this in. 2 times 1 is still 2, plus 3 equals 5. And then we go again. N equals 2. 2 times 2 is 4, plus 3 equals 7. So we start off 5, then 7, then n equals 3. 2 times 3 is 6, plus 3 equals 9. So it keeps going 5, 7, 9, and it keeps going up. Really, this is the 2 times table, but shifted up by 3. Now, they could ask for this. If 187 is in the sequence, what term number will this be? We know the rule is 2n plus 3. We know 187 is in the sequence, so we create an equation. We set 2n plus 3 equal to 187, and now we can solve it. How to get rid of plus 3 on the left? We do the opposite, which is minus 3. From both sides. 2n equals 184. 2n means n times 2 equals 184, so how to move times 2 to the right? We divide 2. N is equal to 184 divide 2, which is equal to 92. As 187 is in the sequence, it is the 92nd term. And not too much of a surprise based on what we got from part 1. Because from 183, if we just went up 2 terms, then we are there. Because it goes 183, 185, and then 187. If you enjoyed this video, why not like it and subscribe to the channel? If you really enjoyed the video, consider making a small donation. Thank you so much. The donation link is in the description.